Howdy. So that's the third attempt to make this video. Time is running out. I think I need to be quick in a way. Space weather in Finland, that's from today. That's now KP7. Some hours ago, modeled GIC, geomagnetically induced currents, into the Finnish power grid. Spiked at more than 4.5 amperes, I guess. I think this A could mean amperes. I'm not too sure. But anyway, there has been some spikes in the power grid. And that's the first of 3 news I want to show you before I try to show you something I made by my own, which seems to be rather important, interesting, up to date, or whatsoever, however you want to call it. So now let's go to the second news. Olkiluoto 3 produces electricity again. Olkiluoto 3 has returned to electricity production according to the website of the nuclear power company Teollisuuden Voima TVO. Olkiluoto 3 currently produces electricity with power about 300 megawatts. Maybe it's about a fifth of what it could do. Anyway, Olkiluoto 3 returned to electricity production on Thursday at approximately 8 in the evening according to the website of the nuclear power company Teollisuuden Voima. Electricity production was suddenly interrupted on Wednesday afternoon when Olkiluoto 3 fell off the main grid as a result of a short circuit fault test conducted by Fingrid. According to TVO, a network failure was caused during the near-fault test, which caused Olkiluoto 3's protection functions to start automatically. The event had no impact on nuclear safety. TVO initially estimated that electricity production could continue as early as Wednesday due to problems with the turbine automation detected at the startup. However, the continuation of production was postponed. And now it seems on Friday that it's finally running again. But there has been problems all the time with that. Biggest nuclear power plant in Europe. Biggest and newest one. It had experienced only some 14 years delay in construction. 14 years? 13 years? That's a lot. And you can bet it wasn't for free. So the price also went up a lot. Now let's go quickly to the third news. Weather news. Even as far as minus 30 degrees south, this year everything will be different. If the forecasts come true, it will be as cold as 30 degrees below zero in southern Finland next week. December begins in Finland with unusually cold weather. In some parts of the country, the temperature will drop a full 10 degrees below average at the beginning of next week. According to the forecast, the air mass would be so cold in Finland that in clear weather next week there would be up to 20 to minus 30 degrees below zero in southernmost Finland. Such strong cold deviations have happened very rarely in my career as a meteorologist. Foreca meteorologist Markku Mäntykannas writes in a weather blog. Normally at the beginning of December the daytime temperature in south and west coast would be around 0 to 1 degrees. And there would be a little frost in a large part of the country. But this year everything will be different. And I have to say that this is translated by Google. And I'm not in reading mode, but I try my best. The unusually cold air is caused by a jet stream that has stalled between southern and central Finland. According to the forecast, the jet flow is not changing, so the milder air will remain far to the south of Finland. Mäntykannas sees similarities in December's monthly forecast to 2010, when Finland experienced the coldest December of the 21st century so far. At that time, temperatures were 6 to 10 degrees colder in the south and central part of the country and 2 to 9 degrees colder in the north than usual. In December of this year, the weather pattern is similar to that of 2010, i.e. the airflow comes from the northeast or east, which is freezing for us. In December 2010, the cold weather continued throughout the month and in fact well into the end of winter, but it is still uncertain how long the cold will last for this December. Story continues after the picture. Mantukanas points out in the weather blog that cloudiness, which significantly affects the temperature, creates challenges for weather forecasting. And when I have been reading this news in the morning, I laughed out loud, I have to admit. And I'm not sure if I should be sorry for that or not, because it seems to me that the meteorologist is complaining about clouds. That cloudiness creates challenges for weather forecasting. Are you serious? Did you know that meteorology is based on the chaos theory because they don't know how it works? And because it is based on chaos theory, they need supercomputers in order to conquer the chaos. That's why you need to be a mathematician if you want to study meteorology. That's why I didn't become a meteorologist, because I suck in mathematics. I hate numbers. But anyway, these were the 3 news, and now I want to read you a part of my most recent paper. And it carries the name Plate Tectonic Issues, the Influence of Electricity in Rock Forming Processes and a Coherent Connection Between Science, Mythology and History of Finland, Part 2. That's straight from academia, that's why it's a bit sketchy to look at, but you can scroll through it. I just want to point out that a wise man once said, anyone can help fill the puzzle. Wallace Thornhill. Geology, an all-encompassing topic, and we are going down in that. Just have to scroll down. There are some microwave experiments shown here as well. And when we go to the last part of this paper, then you will probably figure out why I showed you those few news in the beginning. You find plasma in my microwave and a pebble in the microwave. Blue flames. And copper ore which has been microwaved. What implications do these findings possibly have on our modern society? So I think that's the last part of the paper. Because what do you do with science or whatever experiments if you cannot apply them in any way to our lives? These findings could have great implications on certain modern technologies and the understanding of nature. One of the first things which comes to the author's mind are nuclear waste storing facilities, especially those for long terms. For example, the idea of storing nuclear waste in capsules made of copper deeper underground doesn't sound very good in the author's ears. At the Olkiluoto nuclear power plant in Eurajoki, Finland, the construction, yes, we were just talking about this. The construction of the world's first nuclear waste and storage facility is going on. Not only has the construction of the last reactor been delayed due to many problems and is still not running smoothly, it has also been very expensive, approximately 8.5 billion euros from originally estimated 3 billion euros. The construction started in 2005, but there are still problems. Yesterday, the author noticed in the videos and pictures seen how there's water dripping everywhere into... No, I missed a sentence. But there are still problems. More or less, the same people are constructing Onkamo. the nuclear waste and storage facility. The author noticed in the videos and pictures seen how there is water dripping everywhere into the caves where they are going to store the nuclear waste for hundreds of thousands of years. This alone doesn't really impress positively. The fact that they are planning to store highly radiating nuclear waste in copper barrels seems a dangerous thing to do, especially when the author has witnessed what induced energy can do to rocks. Posiva, the firm building and maintaining the facility in Onkamo, states on their website following, quote, "The inner structure of the spent fuel disposal canister comprises a spherical graphite cased iron component, which serves as the load-bearing component of the canister and as the fuel element placement rack. The sealed copper canister has been designed to act mainly as a corrosion barrier for the cast iron inner part, which in turn contains the fuel elements. The inner structure is sealed with an iron lid. The inner structure of the canister is surrounded by a 5 cm thick copper shell and a copper lid. In the author's opinion, the copper canister might be capable of much more than just functioning as a corrosion barrier." Yeah, check out my microwave experiments. In order to make even a stronger point about why the author thinks that there should be an open conversation about this is the fact that Earth's magnetic field is changing and weakening. This implies that solar activity will have more and more influence on the intensity of the telluric currents. It might not need any more solar activity of a Carrington event magnitude in order to make telluric currents melt things. Because Earth's magnetic field could be about 25% weaker than it was in 1859. At the same time, the amount of dangerous material stored away all over the world gets only bigger. Other modern applications might be also much more easily affected by solar activity than they have been still, let's say, 10 years ago. Another important factor of why the things explained and shown in this paper are important to understand, recognize further, and probably investigated by professionals is weather. Yes, I'm not a professional. I just try to point things out. The SCA, surface conductivity anomaly, was discovered. I didn't discover this, but I found it by the author in the research of a repetitive weather pattern. This already makes a very strong point about the relationship of geological features and weather. Yeah, I found it because I saw it in the clouds and in the weather. Then I found the surface conductivity anomaly. As Earth's magnetic field is getting weaker, magnetic imprints in Earth's crust gain more and more significance on local weather. Weather is an entirely electrical phenomena, and therefore electromagnetic phenomena in Earth's crust, such as metal occurrences and their associated telluric current flows, will influence the weather. As a simple rule of thumb, we can take the right-hand example of current flows. When the thumb current flow direction shows upwards, the magnetic spin is counterclockwise. When the thumb current flow direction shows downwards, we have a clockwise spin. By converting this simple rule into weather, we will notice how it correlates with high and low pressure spinning directions. A low pressure system spins always counterclockwise, and therefore a high pressure system will always spin clockwise. The surface conductivity anomaly is connected to the Kursk magnetic anomaly, which is connected all the way down to the Black Sea. Despite not visible in the magnetic maps, the author thinks that these structures might have dendritical patterns after all. The easiest way to see them are the valleys and rivers. The further up in the mountains you go, the finer the pattern gets. This might be important to understand because all of these different things make up something very big. As explained in the mountain water paper, the author sees every waterway or water body as a part of Earth's electrical circuit. Water reacts very strongly with electricity, not only in the bathtub. A sudden increase of telluric currents, let's say far over what is assumed by experts to be possible today, could have large implications on many places, not only in Finland. The interactions between Earth and sky could possibly be monitored much better with Langmuir measurements or something like atmospheric magnet resonances. I don't know, they should be probably invented such things. If you're bored and an engineer, create one of those things. The understanding of weather from an electrical rather than from a chaotic point of view has practical applications in terms of predictions. The author tries to raise awareness about this topic, not only by making videos, but also by trying to show the mechanics with the tools available. This is a picture I've been showing you many times. The surface conductivity anomaly. And here is just one example of how you can see that the influence of the conductivity anomaly. The spinning directions of the high and low pressure systems. We have the Kursk magnetic anomaly. We have the worst scenario of all is a severe frost and a windless high pressure ridge that persists in the north. And Finland has not received an Olkiluoto 3 unit for commercial use, says Pia Ösch, director of the Energy Supply Department of the National Security Agency. This news is maybe a year old or something. And she never answered. Yeah, I wrote her. She never answered. But anyway, who cares, you know? The surface conductivity anomaly and the Kursk magnetic anomaly with their possible magnetic vortex spinning directions combined with a radar picture and a very full expression from Finnish National Security Agency. The investigation of how those geological imprints in Earth's mantle affect weather patterns are ongoing, and possibly new insights or thoughts will be provided in part number 3. Many things were left still out of the pictures and got touched only briefly, but with this paper the author hopes to spark interest in these topics. A possible example of how ancient patterns are still in use today, the author still would like to challenge the open-mindedness of the reader one more time. Most of the patterns used still today were seen and otherwise experienced by our ancestors. Similar stories of what happened in the past are told all over the world. Things like floods, comets, winds which carried away mountains, raining brimstone, etc. are things which should be understood within a much bigger picture. Yeah, the ancients weren't crazy. Better believe what they are telling us. Anyway, summer is about to end here in Finland. Yeah, I wrote this in the summer. And there is a possibility of having a fierce winter ahead. This is the perfect introduction for the last little topic of this paper, the snowman. You know, I don't really care if you think snowman or talking about the snowman is a scientific topic. Yeah, I don't know. It doesn't matter really, because I'm not a scientist. I just do science. Millions of people made millions of snowmen over the years. Everybody basically knows how a real snowman looks like and what it needs to be called a real or a traditional snowman. He needs a broom, a hat, a scarf, a carrot nose, buttons, a smile, and usually he is made out of 3 balls of snow. Everybody knows, but no one knows why. That's a funny sentence. Why is there a scarf? Why 3 balls of snow? Why the broom? The author did some research about the topic. Yeah, once I realized that's something interesting. And maybe an epiphany also helped. Yeah, I made some research about the topic, and me, came to the conclusion that no one really knows why a snowman has all these features. So there's 3 links where you can go and check it out. There are many more, which is an interesting thing in itself. Let's give it a try. If no one knows, why shouldn't I give it a try? First, we need to remember that the history of our solar system wasn't as peaceful as conventional cosmology tries to suggest. There were many events in the past, of which some have already been discussed earlier. Furthermore, we need to take into consideration the Saturn myth with its associated polar configuration. Earth, Mars, Venus, Saturn, and Jupiter were once perfectly aligned for a while. When this configuration fell apart, many electrical discharge events, weather is an electrical phenomena, happened, of which many stories were told. We have also laboratory experiments which reproduced what ancient people have seen in the sky. Anthony Perret and others. The following picture is an attempt to show certain similarities between the snowman and what other people found out about our history. Before we will take a look at the picture, we want to go through the short list below. The snowman consists of 3 snowballs. And now this is my interpretation: Mars, Venus, and Saturn, or a plasma instability. The red, prolonged nose. Mars dumping material on Earth. The scarf. Often scarves represent aurora. The broom. It is representing a thunderbolt, lightning. The stick arms. They might represent also lightning, but also the dendritic pattern, which is the mark of the lightning. The smile. It presents the planet Saturn, or the bull in the heavens. The buttons, they could represent plasma characters. So here's a picture. I'm very sorry it's not visible entirely, but here's the snowman. Here are some plasma characters, which could be the buttons. There are more plasma characters, which maybe could look like a snowman. We have some Sumerian god and a thunderbolt in his hand. More plasma characters, Squattermans. And Mars dumping material on Earth, which is the carrot nose. And the bull of the heavens, Saturn. A rather wild collection of pictures in order to give a few examples of where the aspects of snowman could have has its origin. There could be many more examples, but from these we might get a good start. Picture credits: Thunderbolts Project movie Signs of an Alien Sky. If you haven't watched it, watch it today. Anthony Perret characteristics for the occurrence of high current sea pinch as recorded in antiquity. And the aurora picture here on the right is made by myself. Whether the snowman is a scientific and relevant or not, whether the snowman topic is scientific and relevant or not, it could still function as an example of how some parts of our history seem to be forgotten whilst the forms and patterns remain. Maybe a sign of the incoherency of widely spread assumptions and diverse scientific branches taken for truth, without questioning the lack of consistency and provability. Never stop wondering and asking. Be curious. And here are all the references. There is a bunch of them. The history of snowmen and stuff like that. But anyway, I just thought I bring this forth because it seems to be rather an actual theme at the moment. There's problems in nuclear power plants. We have geomagnetically induced currents. There is winter, and people probably build snowmen somewhere. Thanks.